The 2.3 lesson just puts together all the things that we've learned in the past couple days. So there are some formulas that you're going to need to remember for your quiz tomorrow, and those are at the top of this note. The first one is your slope formula. Little m stands for slope, and slope is equal to rise over run, which is y2 minus y1 over x2 minus x1. So you're going to need to have that included in your quiz tomorrow. The midpoint of a line segment is a capital M, and it's the coordinates of the midpoint, so we say x comma y, and it's equal to the coordinates of a point. So we use two big brackets. We have the average x, don't forget you're adding, not subtracting, and the average y. The equation of a line in slope y-intercept form is just y equals mx plus b. And the equation, if you're given slope and a point, is m bracket x minus p plus q, where p, q are the coordinates of the point that you're given. Finally, the length of a line segment. Now, you're more than welcome to use the textbook formula if you'd like to. I find it easier to use ab squared is equal to rise squared plus run squared. And this formula, remember, is just a mixture of the slope formula, that's the rise that goes over here, the run that goes over here. They're squared and added just like the Pythagorean theorem. So if you prefer to use the textbook formula, that's all right. Otherwise, you can use this one, rise squared plus run squared, and take them from the slope formula. So the above formulas are used to determine or to prove geometric properties algebraically. So there's many ways to solve different problems, but we'll look at some different applications of these formulas in terms of using geometric shapes and classifying them or solving for different values. Example 1 has us classifying a triangle, and it asks us if the triangle ABC is a right triangle. So before we classified triangles based on their lengths of sides, we talked about scalene, isosceles, or equilateral. In this case, they're asking us, is there a right angle in the triangle? So if we think about a right angle triangle, we know a couple different things. We know, first of all, that it satisfies the Pythagorean theorem. And the second thing we know is that its two sides that form the right angle are perpendicular. So there would theoretically be two ways of proving that a triangle is a right angle triangle. Method 1, I'm not going to show you every single step, I'm just going to talk about it briefly. Method 1 would be to verify the Pythagorean theorem. And in order to verify the Pythagorean theorem, you would have to solve first for all of the lengths of the sides. So first step would be to find the length of AB, BC, and CA. And then you'd have to verify that the Pythagorean theorem works. Now let's plot those points to see what it looks like on the graph. 5, 5 would be approximately right there. That's point A. Negative 3, negative 1 is down here, point B. And 1, negative 3 is right there, point C. So looking at that picture, and we can just connect them very approximately to form a triangle, we would anticipate that the right angle would be this one right here, angle C. So we would test to see if the longest side, AB, if we square that, if it's equal to AC squared plus BC squared. So the first step would be to calculate all lengths. And then we would check or verify, now usually that's a left side, right side statement, if AB squared is equal to BC squared plus CA squared. And that would be the first method, would be using the Pythagorean theorem. That is quite long. That is not the recommended method because it honestly takes a long, long time. When we talk about verifying a right triangle, my recommendation is to go the second method and verify that the right angle exists. So we're going to check if the slopes of BC and the slopes of AC are negative reciprocals. If they are, that'll tell us that AC is perpendicular to BC. So method 2 basically says that triangle ABC is a right triangle if side BC is perpendicular to side AC. And we're going to check and verify if that's true. So let's find the slope of BC. We're using those 2 points, rise over run, so negative 3 minus negative 1 over 1 minus negative 3. that slope is equal to negative 2 over 4. I should probably not write it over there. That's pretty bad form. Let's line up our equal signs like we should be. So equals negative 2 over 4, which reduces to negative 1/2. And the slope of AC is equal to, move the screen over a little bit so we can see. The slope of AC is equal to negative 3 minus 5 over 1 minus 5, which is negative 8 over negative 4, which reduces to positive 2. So those two slopes are clearly negative reciprocals. We can see that they are the flip or the reverse of each other, the reciprocals of each other, and the signs are opposites. Now, how do you prove that they're negative reciprocals? How do you state that in a conclusion? Well, there's a couple different ways you can do it. Either you can write it out and say since negative 1/2 and 2 are negative reciprocals, or since the slope of BC and the slope of AC are negative reciprocals, and you could use those words, negative reciprocals, spell it out. Or, easy mathematical kind of conclusion is, since the slope of BC times the slope of AC is equal to negative 1. Now, if you have reciprocals, or negative reciprocals, when you multiply them together, they'll equal negative 1. If you have reciprocals, it'll equal positive 1. But when you multiply those two numbers together, you don't need to show this, but I'm just showing you, negative 1/2 times 2, those cancel out and equals negative 1. That's the case when you have negative reciprocals. When you multiply them together, they equal negative 1. So when we're proving it, usually it's a really quick and easy way of writing down a conclusion. Since they equal negative 1 when they're multiplied, therefore BC is perpendicular to AC, and triangle ABC is a right triangle. So a little bit of form stuff there. You're going to kind of have to memorize the way to give a conclusion. I'm not fussy with how you write this part out, but you need to give us some kind of sense statement. How do you know that they're perpendicular? Well, because they're negative reciprocals, or because their multiplication equals negative 1. Their product equals negative 1. Okay, so let's look at the next question. Median to a hypotenuse. So example 2 says show that the median from the right angle of the triangle in example 1 is half as long as the hypotenuse. Now, it would be really easy if we had the drawing right here, but I'm going to sketch it again really quickly. We had the points 5, 5 up here. We had negative 3, negative 1 down here. And we had 1, negative 3 right there. So this was our right angle. And it's asking us to prove that the median from this right angle, so median, remember, goes to the midpoint of the opposite side. So this line right there that goes to the midpoint is half as long as the hypotenuse, which is the longest side in the right triangle. So what the question is really asking us to do is to compare AB and CM in our picture. So compare the lengths of the hypotenuse and the median. So to figure out lengths, we need to use our length formula. And I'm going to show you the two calculations, what they would look like. Now, the coordinates of the points, point A was 5, 5. I'm just going to jot it down up here because I forget them. Point B was negative 3, negative 1. Point C was 1, negative 3. And point M we have to figure out. So let's find the midpoint first. The midpoint, which are the coordinates of the midpoint of AB, is equal to 5 plus negative 3 over 2 and 5 plus negative 1 over 2. So 2 over 2 is 1 and 4 over 2 is 2. Those are the coordinates of the midpoint. Does it look like it makes sense? Over 1 up 2? Yes, approximately does in our picture. So we're going to use that point, the coordinates of M, for our calculation of the length of the median. Now let's calculate the length of the median right away. CM is the side we're trying to find. So I'm going to say CM squared is equal to, and I'm going to use the median or the midpoint coordinates with the coordinates of C to find the length of that median. So I'm going to say rise 2 minus negative 3 squared plus run squared. Now they're both 1, so it'll be equal 0, which is fine. And that's supposed to add to CM squared. 2 plus 3 is 5. 5 squared is 25. So the length of CM is the square root of 25, because 1 minus 1 is 0. So CM is 5 units long. That's the length of CM. Now we're going to compare that length with the length of our hypotenuse, which is AB. I'll do that one over here in blue. So AB squared is equal to rise, 5 minus negative 1 squared, plus the run, 5 minus negative 3 squared, which equals 6 squared plus 8 squared. So AB is going to be the square root of that total. 36 plus 64 is 100. So AB is equal to 10 units. Now we need a conclusion, and that tends to be the hardest part. If you can prove that CM is 5 and AB is 10, it should be easy to make a final conclusion. But it's expressing how you know that's true that tends to be difficult for some students. So let's talk about how you'd write a conclusion. I'm going to move the page over a little bit there so I have some more space. You can say it in a couple different ways, but the idea is since the side CM is a half of AB, that's how you know that the median length is half the hypotenuse. So I would probably just say since CM equals AB over 2, or half of AB, therefore the median is half the length of the hypotenuse. Sorry for the messy writing here, folks. This is looking bad today. Okay, so if you wanted to say since 5 equals 10 over 2, as opposed to saying the letters, that works too. As long as you give some kind of a since statement that shows how you know that the median is half the length of the hypotenuse, that's all you need to do. Okay. Now, if you guys notice number 3, example number 3, it's talking about the altitude, and we haven't learned the altitude yet. Originally, it was part of this note when I thought we were going to do it before our quiz, but since you guys have your quiz tomorrow, I think I'm going to stop here for today, and I don't want to confuse the topics that you already know with the new topic of altitude, because it's a slightly different line segment than a median in a normal triangle. So I think what we're going to do is we're going to stop here tonight, and I'm going to encourage you to do the homework questions from this section that are not about altitude. You might only find 1 or 2 in the homework list that has to do with altitude. So do the other ones that are practice for your quiz, and make sure that you do go over the quiz review completely, that you've done all those questions, because they're very, very similar to what's on the quiz tomorrow. I will post the quiz answers in a PDF file on the website later on this evening, and if you guys have any questions, feel free to throw a message up on the message board or to come find me tomorrow in my room at lunch. Have a good night and happy studying.